And we'll talk about PowerPoint slides about pen testing. Sounds like a good way to go. Ken, how much of the nature is my my lavalier mic picking up?
Every now and again I get a little like bit of the wind that I can hear, but that's not it.
No chirpies? That's pretty amazing. All right.
Not that I can notice. No.
Wow, cool. These things are good. All right.
I can't tell whether it's coming from your end or from outside the window.
Cool. Well, just pretend if you're watching, if I reuse this video and you're watching this, you know, months from now, imagine that you're sitting in a quiet grove surrounded by chirping birds. We'll make it like a sort of existential experience. Peace and love and hacking people's computers. Well, and specifically, peace and love and hacking people's web apps is what we're going to talk about today. And well, web apps and, you know, code vulnerabilities in general. So for module A, we'll talk about like all the bad coding decisions that programmers make. And it's not entirely their fault, although it's mostly their fault. But it's not entirely their fault because the incentives of programmers don't align well to the incentives of writing clean code. The incentives of programmers are, you know, get your application to market as quickly as possible, make sure that, you know, we're going fast and breaking things, and the next thing you know, we've decided to neglect all of those secure programming practices that sometimes slow us down when we're trying to do that. So we'll at least touch on memory-related vulnerabilities, and then how vulnerable apps do bad things, like let you see stuff you should not be able to see. And then vulnerabilities focused on authentication and authorization in your apps. So our friends at Microsoft came up with a approach to secure coding. People give Microsoft a hard time, but they did basically like stop their business when they figured out they were having issues with their code being, you know, a hot mess security-wise. Bill Gates wrote his, what is it, Secure Trusted Computing? Platform, am I getting that right? Trustworthy Computing Initiative. So on Tuesday, luckily I have the internet that makes me a lot smarter than I actually am. Oh no, I need to create a free wired account? No. Bill Gates Trustworthy Computing Initiative. Do we have, ooh, a PDF? But yeah, he wrote a memo that said basically that we're under fire from some of our larger customers. This is like right around when I started getting into security. We were dealing with Code Red and NIMDA and stuff, and it was sort of a problem. So they came along, and some of the fruits of that labor are the secure by default, secure by design, and secure by deployment and communications. Those are the, oops, that's the wrong thing I wanted to share. Those are the principles that they laid out. So, you know, that we come up with design practices that involve making sure that secure, if there is an option, right, wait, I'm jumping ahead. Okay, so first we start with design practices where we make security a focus of what we're doing. You know, we build security review into our, nowadays it's into like the Scrum lifecycle, but probably in 2002, that was mostly like into the waterfall of our software development. We include a step that involves securing it. These days, that's probably all DevOps. So, you know, inside of each sprint, there's a security review component as we, you know, go around and around and around, iterating over our software. So when we design software, we think about securing it. It's secure by default because if there's an option, whatever the secure one is, should be the default option. So like in Microsoft operating systems, if the secure option is not to have a user constantly running around as the administrator of a system, we make that happen. With deployment, we're really kind of like feeling the pain of secure deployment in 2021 here. We've got this huge supply chain hack on SolarWinds, and then there's been this huge dependency confusion problem. So this is the Medium article that this Alex Bursin, I'm probably killing his name.
I don't remember hearing about this one.
No? This is ugly. So
Sound good?
it's like, and super relevant to talking about software security. If you've ever done any kind of Python development, you've probably done a pip install something or another, right? I was playing with building payloads for Windows boxes, and one of the easy ways you can get past Defender is like you can take Python and use py to exe to convert it. And so I had to like pip install py to exe. Well, when it does that, Python goes out and it grabs a copy of py.exe from the PyPy site. And that's like one of the many ways like software distributions handle that. Or if you've ever had a Linux distro.
I've not worked with Python, but I have done some Linux stuff, and I do know I have worked with some dependency related stuff before, so I'm at least familiar with that concept.
Right, so you have to go out and you have to get, it's one of the reasons you want a decent, it's like the reason distros exist, because managing dependencies is a nightmare. And there's like some stuff that people are doing to fix that. Putting things into like Docker containers so that all the dependencies are built into that container. Or I know there's some different like Linux app packaging technology that I'm not 100% up to speed on, where they're doing essentially the same thing, bundling everything into one monolithic app. The problem that this guy got paid by hacking into PayPal, who else? Apple, Microsoft, and a bunch of other people by creating, I'll dump the article into the chat, but by creating dependencies, finding out what dependencies look like, and then going out and putting similarly named things with higher version numbers into the public repositories. So like there was analytics-PayPal and Wurfel-PayPal libraries that they were going out and getting. So this guy goes and stands up his own and puts them into publicly available dependencies, which is kind of cool. So, and then the way he...
Weakness there.
What's that? It was huge.
Now that I think about it. Yeah, that's disastrous to think about.
Right, so he gets on these
Edit that.
build servers. Yeah, and there's like no cryptography involved, no security. We actually had a guy, last week's Purdue speaker actually works on exactly this problem. So he did get paid for breaking into a bunch of the different companies out there who have bug bounty programs, and apparently did it legitimately. But unfortunately, since February 9, this is like such an easy attack, and he just basically gave you all the instructions you need on how to do it. It's apparently blown up, and a lot of other organizations are suffering from this. So that deployment piece, man, that is very important. It will get you, and is currently getting people. So that that's like the big biggie. And then the SolarWinds hack is kind of the same idea, that part of the supply chain, part of that deployment piece got hacked. And if you think back, the Xcode hack was kind of along these lines. Somebody put up a hacked version of Apple's Xcode and managed to get into the deployment chains. So those are definitely things you need to be thinking about when building out secure supply chains. And then the last piece Microsoft put in there is communication between developers and the folks who are using the applications and getting like a good solid communications feedback loop going on. So that was pretty big. So people give Microsoft a hard time. You should just chillax. Those guys know what they're doing. So what makes software vulnerable? If you have anything in your software, any component, that takes input from a user, you need to be completely suspicious of that, right? It is the place where bugs happen, where hackable bugs happen in particular. If you have applications that run with more privileges than they need to, so if they can get to directories that they have no business getting to, if they get to execute things as root where they don't need to, or as administrator on a Windows system, or as systems on a Windows system, that can get you into trouble. If we don't have good authentication / authorization to make sure that, particularly in systems that have some kind of user access control going on, like something that you log into, a web app, those will get you into trouble. If you've got a way to disable security controls, that'll be step one of however it gets hacked. So for the longest time, we've had problems with web browsers keeping a copy of the old export grade cryptography in them. Back in the 1990s and 2000s when the government classified cryptography as a munition, and so you had to have a version of Netscape that didn't have the ability to do good crypto. If you can disable those security controls, if you go into like compatibility mode or whatever, that downgrade attack will be like step one for however you're hacking that system. If you're not doing proper error handling, you're potentially introducing places where security can get you into trouble. And then anything output, code, files, or memory that's not protected that can be accessed by users is potentially a problem. If I can get to any kind of sensitive data, anytime there's sensitive data in my system, I need to think through all the places that that's potentially accessible. And then integrity controls like signing your code. So if you have a piece of software on your system, I think I happen to have a piece of software that is unsigned on my system. You should probably not touch it, or not trust it. That's what I meant to say. Okay. It's like out.exe here. Is an application, and that's about all we know about it. So you probably don't want to trust those kind of things that don't have integrity controls like code signing, whereas sysinternals is probably very good about signing their code. What with them being owned by Microsoft and all. So on systems that care about security, having digitally signed code is a big deal. So those are the things we should be concerned about. So there's bunches of like buckets you can throw your exploits into, when we're talking about them. Anything that's manipulating header information, anything that can play with memory. That dependency bug we were talking about, like that is probably as big as like the whole smash the stack for fun and profit thing was back in the 90s. and that was a big memory exploit attack that we're not going to make you do for this class, but I have been forced to do for other classes. Where you write a article for FRAC and you wind up in the IEEE. But this was a huge issue where you would overwrite memory and get it to execute and blow things up. Next thing you know, you're running attacker's code inside of whatever app you managed to do that to. So usually you would provide some sort of user input. The user input would overrun the memory. The system would run that. Bad news bears. Anytime I can fake authentication, so if I can, attack the way that you log into a system, if I can do like a replay attack where I record the communication between the two machines as they connect, those are authentication attacks. I can inject something to your application where perhaps I can, become a man in the middle between a web app and a client and put things in there. Data exposure is any sort of vulnerability where we're seeing stuff we shouldn't be seeing. Directory transversal is a whole class of attacks where basically, because we have a bad handle on how, like this was a big deal with Apache, but I think there's still one in, the last one I remember was like WinRAR. Yeah, had a PS, exploit DB, useful place to know. 2018, that's not that old. There's a directory traversal vulnerability when crafting the file name of an ACE format vulnerability. When you do that with specific patterns, the destination folder is ignored and becomes an actual direct, you're welcome. It becomes an actual like directory on the system as opposed to being somewhere inside of it. Also, still available on Metasploit. I had one of my first cybersecurity students just take a job over there at Rapid7. Sent me an email, all proud about it. And I'm kind of proud about it too. It's a cool place to work. So that's directory traversal. Arbitrary code execution is when I can run arbitrary code. So I can get your app to execute my code. If you ever do like a pen testing CTF with a web app, oftentimes being able to trick a web server into running your code either with like a command injection where into the string of the URL I can somehow manipulate and put in a command, or the arbitrary code execution piece would be like, I managed to get it to run something because it's got, like the last one that came to mind when I was talking about that was a CTF where there was like a cron job that ran every so often, and you could actually use directory traversal to put a file into that cron job and then it would run that thing for you. So it was pretty interesting. So in terms of memory vulnerabilities, you've got the buffer overflow we were talking about. So you would have, in C and other low-level languages where you are allowed to do more memory allocation that maybe people should be up to. For the vast majority of programs, writing them in C is probably overkill. But you have this buffer set aside. You make some set of characters X amount long, and you let a user provide input to it, and they provide input that is like X plus some beyond that. And so you'd set up this buffer, this buffer, and they overflowed it by adding too much to it. And then we decided that my new favorite way for me to talk about integer overflow was with the what's his name? The Gandhi aggression, where we, what is it? It was the,
Yeah, where he, his default, what was it, aggression was 2, but that meant that minus, or no, his default was 1.
right, it was
Then
almost no aggression.
Yep, 1 out of 10, and then when he would almost always pick a certain like government choice. I think it was democracy, and that would give him a -2 to his aggression score, which would then roll him over to like 511.
Right, he would go all the way to the, there would be an integer overflow where it would blow way past whatever it's supposed to be, and I like the,
Like an underflow, or is it still an overflow?
I mean 6 of one, half a dozen of the other. It's the same idea. Underflow would be when it goes the other way, but it's semantics. Same idea. Like you're expecting 999 and you get 0, or you're expecting, you know, Gandhi to have a violence level of 1, and instead he's got a violence level of negative, yeah, -2 to the 8th minus 1. So that's my new favorite way to talk about integer overflows. He would, but similar things like that's a fun example of how that can happen. I mean, they can really jack up your web app or your regular app if you don't keep that in mind. And then memory leaks. If you've ever had an app where it runs and runs and runs and like your computer gets slower and slower and slower, oftentimes what's going on is that memory is somebody's doing one of these where they're using a language that requires memory management by the human, and the human's doing a poor job of it. We keep allocating memory, and like there's somewhere where we allocate memory, and then we forget to free it back up, and then it runs a little longer, and then we allocate more memory, and then we forget to free it up, and then we allocate some more memory. And since computers do things in loops and sometimes really fast, occasionally that just keeps happening until you run out of memory and your computer blows up. So not great. Poor development skills is what's going on there. So those are big, like memory-related vulnerabilities. Race conditions where you get two things racing against each other are tricky and crop up, especially if you've got like multiple threads running on a single system. So you've got errors like the time of check to time of use error, where you set a variable somewhere that's like, I'm going to not allow you to log in, and then the program runs for a little bit, and that value changes, like, okay, Tyler can log in, and the time of use happens after we checked that, so we can't verify that it's doing what we think it should be doing. I guess that's an okay way to explain that. So one of those bugs can eventually get you into a place where you can, like if you can change one of those values before the time of use, you can get into trouble. It can get ugly. Sensitive information is what we've been going over. If you can see the source code of a program, if you can't see the source code of the program, if you can, great. It makes life a lot easier. But even without the source code of a program, you can use like strings to look at the source code of a program. If not the source code of a program, you can at least look at the strings or the human readable stuff inside of a program. So on this one I have this out exe. This is packed. I don't know if it'll actually be able to read any strings out of it. Let's see. Oh yeah, there's a bunch of them in there. So those are all the things that look like human readable texts inside of that. And I think, is that it? No. What's the, what? Or maybe I just typoed it. Yeah. So I told it, show me strings that are longer than 5 characters. So sometimes, like, if you are not security conscious when you're developing your application, you might sit down and develop an app that tells us stuff you don't want people to tell you. And this one, I don't think I have anything in there that is too interesting. So that's always good. The other place you can go to hunt down info exposure inside of applications is in RAM. That is relatively easy. There we go. Relatively easy to get to as well. There are plenty of applications like Process Hacker here that will let you look inside of the inner workings of an application and take a look at like what's going on in the memory of that application. Similarly, they'll have things like the ability to go out there and get strings. I think I need to promote this thing to administrator level authority before it can start getting into too much trouble. If you ever do a development class and you start running your applications, Process Hacker is a fun way to go through and like look at what your applications are actually up to. So you can see what is going on with them in real time. Like in this Chrome process, the handles it's using, the applications it's running, and then inside of the memory, again, you can go through and you can look for strings of 10 characters or longer and find what's going on. There are techniques to encrypt memory in use, but it's a challenge, but a thing that can be done. So you can like run into, in the memory of running processes, find all sorts of useful things like certificates, like passwords, private keys, all that kind of stuff. In fact, if you're doing forensic analysis on a system that is like currently encoding things with malware, that might be one of your only chances to catch the keys for that memory or for that encryption before they're gone. But same thing's true inside of databases, temp files, anything else used by an application. If your adversary can poke around at it, they're going to have the opportunity to find stuff. So definitely useful if you're going to go through and reverse engineer an app and attack it. How you handle errors is important to a developer. So it is a good plan to, if you really care about security, you'll go as far as fuzzing your application, throwing all kinds of garbage at it to see if something breaks. But it certainly should be like a part of a regular development cycle to go through and try that. Ideally, you fail safe as opposed to failing open. So if there are two ways the application can go when it handles an error, ideally you would like it to just say, I think I found an error, and shut down, as opposed to try and continue on with what could potentially be bad data. So if you do have a setup where you're doing multiple things, it's probably better to break them down into little pieces in order to prevent the bad guys or the end users, whoever that may be, information about it. So you want your error messages not to say things like, your password is incorrect, but your username is okay on a web app, because then I know, you've leaked information to me that tells me, well, now I know I've got a username that's right, now all I have to do is work on the password. So logging those errors is a better idea. To log files that can only be read by the appropriate parties. So in Windows, you would send it to the application log, and in theory, only people who are supposed to be reading that can read that. For authentication, credentials are a problem. Things that can be brute forced. I wish I had I probably don't. I saw a cute Gandalf trying to open the door to the mines of Moria. Maybe it was Melon 1, or maybe it was an uppercase M, where he's trying to figure out how to get in to that door that you have to say friend and pass. If there are default credentials, that's a bad thing. You don't want folks to be able to log into your web apps using something that they can find on the internet, or routers are notorious for doing that.
Yeah, I have one too many family members who thought it was a great idea to just stick with their default login information.
Yeah, not a good move. And not a good move on the side of the developers to let them do that. I was actually kind of pleasantly surprised when I set up my mom's internet when she moved a couple of months ago, that the routers come with a predictable but pretty secure password where they had used the a random string of numbers plus the phone number of the subscriber or something to set the initial password. So I was like, good for you guys, not bad.
Yeah, I've got some family that they're still using one, but at least it's like semi-secure because it uses 2 randomized words and then a randomized series of numbers.
That's not too bad. And they were just like, that's the Wi-Fi password, and there's no way we could possibly change that. Came down from on high.
One of them is fully capable of it. Is just too lazy to.
Ah, well.
That because he'd be the one that would have to change everybody else's devices.
Yeah, I'm kind of in that boat. I've decided that the old password will be the one for the dirty network, and then the trusted network got a new password. And now I'm just migrating the things I really care about to the trusted network.
That's how it goes. There's some people that can't enter their own Wi-Fi passwords into their phone.
For sure. So those are important. The other thing you can sometimes find in strings is if somebody hard-coded like an API key or other cryptographic info into an application. So you'll hear about web apps, or not web apps, like apps getting cracked like that, where somebody's left a hard-coded key in there that they're using to talk to something. Those are not good. Don't let everybody have access to the hard stuff. So specifically for users and groups, given access to doing important things like administrative things, like working on system files, like writing outside of the directory that the app is supposed to be locked into, are authorization vulnerabilities, things where it's doing stuff that it really shouldn't be authorized to do. In web apps, you can get into a lot of trouble. Anybody, in the world has access to the web, which is I harp on this a lot in my web apps classes. Like the minute you turn on your web app, you are competing with the world's best hackers. So if you're doing anything that anybody might care about, you need to take security very seriously. Signed code is, trustworthy if you trust the signer, right? If that app we looked at, that sysinternals app, right? Signed by Microsoft, totally trust it. Out.exe here, not signed by anybody, and I think it says Professor Rosemont when I run it, so that's definitely not secure. Probably shady. So that app can't be trusted, and it's not signed, so you could modify it and make it do whatever it is you wanted it to do. So if there's unsigned code out there, go grab it. It is true that signing something just means that Microsoft was willing to put their reputation on the line for strings.exe. if you are looking at a live system and analyzing it, you can get, you can look at the signer of the apps as part of the process view. So these are all the apps that are signed and trusted on my system, and actually that's nice, I'm not running anything that is not. Oh, not true. So this Synaptics audio tool isn't signed. GoPro didn't sign their webcam app.
That seems a little sketchy.
It is actually really sketchy. To get the app, you have to join their like Facebook community, and they give you a link. So it is kind of sketchy, but it's like very beta software, and it doesn't work very well at all. It's kind of garbage, and I should probably take it out. The other thing that's useful to look at with these sorts of things is like the path to them. What do they call it in here? Sometimes path or sometimes command line. That's why I was looking up here. I usually actually keep it going most of the time. There it is. So knowing like the exact file to an app. I can't believe Rescue Time doesn't sign their stuff. Or OpenVPN. Or that utility service that looks pretty sketch, and I should probably just throw that bad boy into VirusTotal right now. Ooh, somebody thinks it's malicious. Although many people don't. But not knowing what it does. Oh, the other thing you can do, of course, is you can just Google the process. Component of the Connexkent Smart Audio. So that's why you should sign your code, so people don't freak out. And then like the people who write my audio drivers are just jank. And I think the audio driver on my laptop doesn't do audio anymore. If you can like get upstream of that and compromise somebody's signing keys, boy, it's off to the races. And that's happened a handful of times to some big vendors. Too much shenanigan. That much only works, though, if your operating system cares about it. So in a lot of corporate environments, it's a good move to use code signing as the starting point for creating like a whitelist of the code you're going to allow to run on your network. All right, so that is all the things for Module A. Let's take a pause here.